Cool. All right. Thanks, folks. Got Fabio joining us today to talk about how to simplify your orchestration with Ansible and Podman.
Thank you. So today we are going to discuss a little bit why should we do this. First of all, because let's start in the correct way. Then we will see how we can automate containers with Ansible, obviously. The first approach is what someone can assume from the documentation. There is also an alternative approach, and then we'll discuss a little bit about SE Linux as well as Kubernetes objects. And then also we'll wrap up and do some conclusions out of that. So about me, I've been working in IT for the last 20 odd years. I've been very involved into the open source space. At the moment I do sit in FESCO, which is the Fedora Engineering Steering Committee. And I've been an Ansible user for 10 plus years. And I've also contributed over the course of years, at least a little bit to the community as well. And I do work with Red Hat. So why is this a thing? The problem, so usually every time people say container, they also think about Kubernetes. That's the go-to solution to any container problem, and sometimes it's not even containers problem. The problem with Kubernetes is, first of all, it's heavy. So the overhead that you will have to run your containers is very high. Second point, it's complex, and it does have a steep learning curve, which might not be what you're looking for. And the third problem that it has is that it's complex. Even people that have a lot of experience with Kubernetes still have issues sometimes with it, because it's a very complex piece that starts from the point that is, it has potential agreement on the state of the cluster, so everything is complex around that. Now, let's be very clear. There are problems that are Kubernetes-shaped problems. So if you have one of those, you should not try anything else but Kubernetes. One case is if you need to provide a container as a service solution to someone else. In that case, probably, Kubernetes is the best solution. Very, very probably. Second option is if you need deployment that auto-scale horizontally. So horizontal auto-scaling means that you are now running one pod, and then you want to run 2 on 2 different machines, 5 on 5 different machines. And if you want the machine, the system, to orchestrate this for you, probably you need Kubernetes or a similar tool. And the third aspect is the auto-placement. So if you need to have an intelligence somewhere that is able to schedule a pod on one specific machine or another machine, then you will need something like Kubernetes. Now, as you can see, there are a lot of use cases where those three are not criteria that are important for you, because a lot of times you just need to run a bunch of containers on a bunch of machines, and that's it. And for all those cases, Kubernetes might not be the best solution for you, I think. So we can have Ansible helping with us. Ozzy, if you are here, I assume that you all know what Ansible is. Is there anyone that has no idea what Ansible is? No? Perfect. You are in the right room. So Ansible can help you with this. There is Podman, that is a tool. You can use Docker if you want, but let's say that you are going to use Podman, because Podman has a few advantages, and we'll see it over the course of the whole presentation as well. But one of the core points is that Podman is like Docker, but it's daemonless and rootless, which means that you don't have a daemon to take care of, and you don't need root. That does not mean that you cannot run it as root, you can, but that's not a hard requirement. And also, it has been recently donated to the CNCF, so we are talking about a fully foundation-based open source project. It was previously developed by Red Hat, but now Red Hat is still developing it, but is owned by the CNCF. Some key features that are going to be interesting for us. First of all, the fact that he is fully compatible with the Docker CLI, so if you are used to that, that's perfect. You can still do exactly the same commands. Second aspect is that it does support OCI containers, which means that any container that is an OCI container will be able to run properly on Podman. And the third aspect is differently from Docker itself, you can actually run Kubernetes objects on Podman, which means that if you have a Kubernetes definition of a pod, for instance, that thing will be able to run on Podman. So those are interesting points that will be also the basis on why Podman instead of Docker, for instance. And the way you can automate very easily this thing, if you read the documentation, is with the Ansible module for Podman, which are the containers.podman. Those are 29 modules and 3 plugins, so you have plenty of tools to do that. And the logic behind it could be that the workflow could be you use Ansible to deploy and manage containers with Podman, and also you use Ansible to start, stop, and potentially update containers. That seems an approach from the documentation. I think that that approach can be okay for certain use cases, but it will probably not be okay if you want to run long-term, long-lasting services within containers. Because then obviously, as soon as you start the machine, that does not work anymore. So you kind of need something more than just this. So what I would like to propose to you today is an alternative approach. The alternative approach starts with the addition of a couple more tools to the one that we have already discussed. And the first one is systemd. So systemd is probably already on your machine, in the sense that it is in all the major distributions. There are some distributions that do not contain systemd. So if that's the case for you, that's a little bit more complex. But if you are on any enterprise Linux version, any Fedora, Debian, or Ubuntu, and many others, you already have systemd. Now, what is systemd? Systemd is a service manager for Linux, which basically means that it manages services. So it controls system processes, services, dependencies. It does all the things that you would expect from a tool to actually run services on a machine. In fact, systemd is also known as PID1. And the reason for it being PID1 is because it's the first service that gets started after the kernel, and then it will start every single service on your machine. It replaces other init systems. In the past there was CSP init, there was Upstart for a short period of time. Systemd is now considered the default instead of those. And some interesting features from our perspective is that obviously it's made to manage long-running services. Also, it does support dependency management, so we can declare that one specific service will need one or more other services to be already running at any given moment in time, and also supports auto restarts, so if something crashes, it can restart it. And also, it provides robust logging, monitoring, and everything else you would usually need if you are running long-term services. Now, that's normal because the whole point of the system is to run long-term services. And also, it allows custom extensions to itself. So it does have a configuration management, configuration file format, but you can actually extend it and do interesting stuff with that. So why systemd for container management? First of all, it does enable native services alike for containers. And second, it does simplify all the parts of the startup, shutdown, restarts of services. So effectively, it does provide us a lot of the features that usually Kubernetes provides to us for the containers. But we need to remember that systemd is always running within one machine. So we have to deliberately say to that specific machine, you are going to run those containers, and systemd will be able to do it for us. But those containers will not move to another machine, maybe if the first one crashes or something like that. So that stuff is something that you need to take care of and you need to control and manage. So there is another aspect, another component, let's say, even if it's not really a component anymore, which is Quadlet. Quadlet is a systemd helper for Podman. This is how it was described into the documentation. And the fact is that it does extend systemd to simplify the creation of systemd units, which are the configuration files for systemd, to run containers. And it does allow then us to manage containers as if they are services, normal systemd services. And technically, Quadlet does not exist anymore because it has been merged into Podman, one part, and systemd into the other part. So technically, it does not exist anymore, but it's very easy to still find the name Quadlet if you are looking for it in for documentation sake of it on Google or those kind of things. So what are Quadlet's key features? First of all, it does use the declarative configuration for the container management. It does support auto restarts and dependencies, because technically it's not Quadlet itself, it's systemd that does it. And also, it enables that integration between containers and services, which means that you can have, for instance, let's say an application that is running into a container, but still requires some dependencies that are not other containers, but are services running on the host machine. And you can do it, and also you can mix and match it however you want. So, like, you can also have a service running natively on the machine that depends on a container, or on another service that is running within a container on the same machine. So that is very flexible. Why Quadlet and not other approaches? First of all, it's very simple. It removes all the complexity of configuring systemd, Podman, and everything else in between. And it does reduce the complexity and the manual stuff that you have to do in the process. Also, it's ideal for those long-term persistent, let's say, containers. Now, a very basic example on how it looks like a configuration file to run a container from systemd with Quadlet is this one. So it's a mighty 3 lines of ini file. So you first declare that you are in the container space for the systemd configuration. You provide a name for it and an image. And you will be able to run that container as a service in systemd with just this. Now, actually, you also need those couple if you want to be able to enable it and run it, for instance, at boot and those kind of things. But still, it's within 5 lines. So I would say it's fairly straightforward. So if we have this file that clearly allow us to run a container as a service, then what could be the strategy to run containers with Ansible on machines? So my strategy is, first of all, place the file, the one that we have just discussed. Second, reload systemd daemons. You will have to do this thing. That is how systemd works. And third, start and potentially enable the daemon, and you are set. So this feels a little bit more reasonable than the previous approach to me. So let's see what Ansible code actually that maps to. So this is the code. At least, well, it's not too big, but the first one is ensure the container launcher is up to date. So effectively, we are dropping that file that we have seen into /etc/container/systemd/ whatever your service name is, .container, and we will provide it some permission settings. So effectively, owned by root, group root, and 644. So basically, only a root can change it. This is up to you. If you want all your users to change your systemd units, go for it. Not very suggested though. I also register immediately the systemd daemon variable, so basically has a file being placed there or modified there, so that we can then restart services potentially, and also notify the restart service that is defined as this. So effectively it's just the built-in.service, which is the way you would handle systemd operations, and say that you want it restarted. And then the third thing that we do is ensure that the service are started and enabled, and we have the reload systemd daemons first if needed. So if we have changed something in the first step, then we are going to reload the daemons. And then the third step is that we ensure that the service are started and running and enabled. So effectively, we will be doing state started, enabled through. So we are not doing anything too complex here. And also, as you can see, the code is very independent from the container that you want to run. Let's put it this way. So the only dependence parts will be the name of this service and the name here of my service and here. So if you put variables there, then it becomes fully independent of the specific container that you want to run. Now, this is basically a very easy way to run a container. There are a few things that you can do in addition to this, because so far we are just running a container as a service and nothing more. But we have discussed about dependencies, for instance. So how can we inject dependencies into this? A nice part about how the whole systemd/codelet thing works is that you can inject into the codelet configuration any systemd configuration. So the way you do it in systemd is this one: unit, and then and then you put whatever services you want to be sure that have already been started before your service starts. And you can simply add those 2 lines to the 5 lines that we discussed at a few slides before, and it will just work. Obviously, remember to reload the daemons every time, otherwise you will find weird behaviors. Another aspect is that very often, when you run a container, you want to pass a number of environmental variables to that containers, because usually containers are run in a way, or are written in a way, where basically to make them useful, you will want to pass a bunch of variables there. So there are various options, but I would say the easiest one is to simply add into the container space that we already declared. That was where we put the name of the container as well as the image. You can pass the environment variable and then the key and the value that you want to be present into the container. Now, if you have more than one, you simply add more than one line to that. You can absolutely do that. They are not rewriting each other unless also you have the same key, but you should not have the same key for 2 different variables. Now, if you're running a service, probably you will want to expose a port. That's a fairly standard way of running services, because in the end, if it's a service and it does not expose anything, probably it's not that useful. And the way you do it is this one. So effectively, you just add one more line to that container declaration, where you say that you want to publish port and then equal, and then the usual Kubernetes like bindings. So effectively, the first one would be the internal port, so the port within the container, and the second one would be the port outside the container, and then you can potentially declare /TCP, which means TCP ports, or not put anything there, and then it will be both TCP, UDP, and all the rest. Now, another thing that is fairly common as well is volumes, because there is data. Things are usually not stateless. So the way to do it is, again, into containers, volume equal the external volume, and then the external path, the external, again, external path and then internal path. Fairly straightforward. Yes.
Can it be multiple?
Yes, it can be multiple as well. You can simply, declare it 10 times, and it's fine. It's like, because in the end, what really happens behind the scene is that Codelet will transform this declaration into a systemd standard unit that calls Podman plus a bunch of arguments on inline arguments. And in Podman you can have how many, well, I think there is a limit, probably 128 or 256 or something like that, number of volumes that you can connect at the same time. And the same thing applies here. So, as we know though, you should be using SE Linux, or there is this thing around that is called SE Linux. SE Linux is mandatory access control, which means that differently from the standard way of ensuring security around files, which is that you declare that this file is owned by this user and that group, and you set permissions for that user, that group, and then the others. Mandatory access control means that the administrator of the system decides that that specific file or every file that has matches specific regex will have special permissions or denials. And why use SE Linux? It does provide fine-grained access control, way more than the standard DAC approach. It limits damages from vulnerabilities and enforces least privilege principles, because obviously by default you cannot do anything unless you are allowed to. And that's also the reason why many people also hate it, because it does create problems sometimes if it's not well configured, obviously. So why use SE Linux? Containers do not contain. This is a reality. We have seen it multiple times. We have had containers for the last 10 years. We had, I think, 6, 7 very serious CVEs around containers, and in all those cases, the container did not contain the service, and it was possible for an attacker to actually escape the container. Now, since we are talking about containers on a Linux system, that means that if someone escapes that the container they are into the base operating system, and therefore they can attack the base operating system as well as every single other container that is running on the same machine. So, probably not the best thing. Therefore, SE Linux is important. And you should use it. Really, you should use it. For containers is even more important because people often associate container equals security. Container is not equal security. Container is other stuff, is C groups, is ability to manage and control resources to be used or consumed, but not to have security. There are other tools for security. SE Linux is one of those. And by the way, every single CVE about the container space was completely mitigated by the presence of SE Linux. So if you had SE Linux on, you would have no issue with any of those security vulnerability that container had. So if you want to use SE Linux, yes.
What if we run the container as an ordinary user? So if you put a user group in nobody notebook in your service, then it doesn't run as a root.
Yes, I mean, obviously, if you're running, yes, the question is, what happens if we run the container as a non-root user? Would that be better? Yes, it's better, unless obviously you're running more than one container from the same user. In that case, you would have the issue. And also, one of the issues in general is that even limited users often have way more power into a system that you would be comfortable with an attacker having. So, yes, obviously there are a lot of ways to mitigate security issues. There is no silver bullet here. But SE Linux has always been one of the most important ones. So, if you want to run with SE Linux on SE Linux system and you do not want to mount any volume, it's very easy because you do exactly the same thing that we did before, everything works out of the box. The only exception is if you want to mount volumes, because then you arrive into the details of the SE Linux security. So what you need to do is a couple of things. First of all, create the volumes of that you want to mount. Podman will not be able to mount a volume that does not exist. So your path needs to exist in the first place. Podman will not create it for you. So remember to create it beforehand if you want to use it. And second, what you do is simply create a rule for systemd, so that is for SE Linux, so that is aware that that specific folder will have the correct tagging, which is a container kind of tagging. And another thing you have to do is to actually add a column Z to the volume mount. There are also other flags that you can add, read-only flags or other kind of flags. So that's a very interesting thing. But in the SE Linux case, there is the Z one. Actually, there are two, because there is capitalized Z and lower cap Z. The big difference between the two is that if you use the big cap Z, capitalized Z, when the pod starts, that mount points will be retagged with the correct SE Linux tags for that run. If you use this one, it will not be retagged. So you have to ensure that it's already correctly tagged. So if it's like a container that just starts, it can be okay with capitalized Z. It's easier. If you have to do something more complex, then the lowercase z is the correct one. Now, if we go to a folder, let's say that I have those three services, and I keep them in /var/opt, and I do create one folder for every service, because then I want to mount those folders for the various containers I have. And if you do ls with a --Z, you will get the SE Linux tags of files or folders. So, and are those, to be clear. And as you can see, we have before declared that it was a container file T, so the tag was container file T. But we do actually have a little bit more stuff here. The reason why we have more stuff there is because at every single container launch, Podman will create one of these, so S0, C, blah, blah, comma C, something else, which basically is, so SE Linux is multi-level security, multi-category security. So S0 means all levels for a specific set of category, and C whatever is a category. So effectively, we are creating one category for every container, which means that whatever happens in that container user that escaped the container somehow will never be able to exit from that SE Linux category. So it's another layer of security. So going back to the question about what if we use different users, that's perfect, but this will give you another layer of security, and obviously the more layer of security you have, the better probability you have that you don't get compromised. So interesting enough, as I say, every time you run a container with capitalized Z, a new category gets created, everything gets retagged for that specific category, so everything works, but no other container will be able to read your files, which might be okay in some cases, or maybe in other cases might not. Let's say that you have two containers that have to access the same disk or the same volume. In that case, obviously, it will not work. So how to do it? You can do a share access container, which simply you declare into the usual file, container security level equal S0. What it will create is, well, also, as you can imagine, shared access is not very good for security, but in this case it's very not good for security, because what it will create is this kind of thing, where basically it's only S0, which means that every single category every single process associated with every single category will be able to access your files. Which means that in this case, all those other services will be able to read that fourth service folder, while the service 4 will only be able to read its own one, because the others have a category specified. So this might be okay for your use case, but probably is not. There is a better approach for this, and the better approach starts with what is called basically tagging directly with a specific set of categories, so that effectively it does ensure that only those will work. So if we do this, and you have to do it in all containers that have to share obviously their files, not only on one, and it will need to be the same string. Basically, you are setting one specific string to every single container that have to share files, and SE Linux will be happy because it's the same string. So the way it would look like is something more like this, like service 5, where you have 47.514, and that was exactly the same one as service 3. So in this scenario, what we will have is that service 3 and service 5 will be able to read each other's folder. None of the other services will be able to read those folders. In the other hand, as before, service 4 will only be able to read its own folders, but everyone will be able to read service 4 folder. So you need to be aware of this, and the solution of using, this last one is the suggested one, because maybe today all your containers are okay to read one specific volume, but maybe tomorrow you will run one more container that should not be. So it's better to use this approach, so that you are setting in a positive way, not in a negative way, the permissions. So Kubernetes objects. Yes, a question.
How do you know the category number on the format?
You made it up. Simple enough. Because whatever you declare here will be exactly the one that is going to be executed every single time for that container. So if you don't declare anything, Podman will create one by its own, but if you declare one, that one will be used.
Can I make a shared volume for the two containers so that they have their own volume, as you showed here with, what was it, 2 and 5, 3 and 5? But if they can now read each other's folders, but I want one shared folder and one private folder.
Okay, so the question is, can you make one shared folder and one non-shared folder? Yes, you can. It's a little bit more complex, because you will have to provide multiple categories for one container and only one category for the other container, and then properly tag the volumes that need to be shared with the category that is shared, and the ones that are not shared with the other category. So it can be done. SE Linux is very powerful. The annoying part of it is that the tooling for debugging the problems are not that user-friendly. So you need to be sure that you know what you are doing. You have read enough the documentation to actually do it correctly at the first time. Just because debugging it is annoying. Yes?
How can we ensure the category is free?
How can we ensure that the category is free? So it's basically, if you are setting all the categories yourself, then you are the one assuring that they are free. If Podman, when Podman starts, it checks that the category that is going to be used, it's not used already. And also the reason why you see two numbers, in this case is C47, C514, is because you have 999 categories for every C that you declare. And if you declare it like this, it needs to be both in category X and Epsilon. So that becomes basically a 1 in a million possibility of a clash. So in theory, you check it beforehand, Podman will check beforehand, and that's how you would ensure it. Any other questions? No? Okay. So, Kubernetes objects. We have said that Podman is able to run Kubernetes objects. So, can we run in the same way also Kubernetes objects in with Podlet and everything else? And the answer is yes. With another very complex systemd configuration file that, as usual, we are going to install it so that effectively we can then enable it to run as boot. And then in the cube space, we are going to put YAML equal my file or whatever your file name is .yaml. The only thing to be aware of is that the YAML file in this case needs to be in the same directory as the container file. So be sure to place it in /etc/systemd/system as well. Otherwise it does not work. And the way it looks like is a normal Kubernetes object. This is a pod declaration. In this case for HA proxy, you would have, this is the name of the container that you want to run. This is the image, ports, volumes, and potentially you can have more than one container running in the pod, and everything works. Also, remember to declare volumes if you want to mount them, otherwise also they will not work. But it's fairly straightforward. Also, this allows us to have, let's say, a Kubernetes configuration, because maybe, let's say that I have a software that sometimes I deploy on Podman, other times I deploy on Kubernetes, but I want to be sure that they look the same. So effectively what you can do is just have those Kubernetes configurations, and then sometimes you apply them with kubectl, other times you apply them with Podman and Quotlet, and it will look exactly the same. Also, you can automate kubectl via Ansible, you can automate this stuff via Ansible as we described. So with Ansible, you can simply have maybe a variable or something like that, that in this system, you are going to deploy it as Kubernetes, in the other one as Podman. Question?
You can also specify the as a Linux things here then?
Can you also specify the Linux here, stuff here? Yes, you can. SC Linux is also supported in Kubernetes. So all the things that we discussed before, it's also through here, with a couple of exceptions about how exactly you specify the categories. Because the way it works into the Kubernetes space is that a pod will get its own category set. So all volumes declared within a pod will be seeable, visible from any container within the same pod. So you don't need to play with categories and that kind of things. If you want to have two containers that see the same volume, you will simply declare them, one here and one just after that one, and they will both see that volume. Okay, other questions? No? Perfect. So, wrapping up, first of all, Kubernetes is good for Kubernetes shared problems. That's fine. There are a lot of non-Kubernetes shared problems. In those cases, Ansible and Podman can be great to run containers. And also, it's a very straightforward solution. I think that was fairly clear, hopefully. Any questions? Also, there is a QR code for this presentation. After this slide, there is another slide with a few links if you want to, to be able to click around stuff for documentation and so on, and you will be able to download the sites there. Also, I will upload them on the conference website as well. Question?
Now that you teased us so badly with that, because we template with Ginger for a long time those systemd units, which do then the exec around Podman, and it kind of works, but it's ugly, and then right up. So to get that basically rolling for us or to use it, we don't need a new systemd version, right? Because it's not in systemd natively, right?
So the question is, to use everything that we just discussed, do we need something different, such as a new systemd version or something like that? Yes and no. Yes, you will need a new systemd version, but it's already available in RHEL 8, RHEL 9 will be a RHEL 10. It's available in every supported Fedora versions. I would say at least the latest version of Debian is there. Ubuntu, at least last couple of releases is there. So yes, even though you will need a relatively new version of systemd, it's not the last one. It's like, I think as long as it has been released in the last year and a half, it's okay. So if you have your system reasonably up to date, you are fine. You can directly do this.
But for RHEL, you backported that basically.
For RHEL, we backported it. Yes, and also we updated stuff. So as long as you have the latest version of RHEL 8 or RHEL 9, whatever you are running, you are set.
Do I need anything else than the systemd?
Do I need anything else except systemd? Yes, you need Podman.
And then also the latest something version from?
The latest version of Podman, no. Same thing. It's like roughly 1.5 years ago. As long as you have roughly an up-to-date version of systemd and Podman, you are set.
Nice. Very nice.
So I already had it.
You already?
So probably you already have it. Yes. You're simply not leveraging it.
Yeah, just stupid to not know it. Thanks for your thought.
Absolutely.
Shell script from
Yes.
systemd.
Docker files, there's some kind of mechanism to convert them to so systemd units.
So if we have Docker files, is there a way to convert it to systemd units? I would say no, because you don't need to. Because a Docker file is made to create container images. We are just running container images. We assume that you have already created the container image however you want, with the Docker file, with the container file, with Ansible, with whatever method you usually use. You have pushed it to a registry, and then we are just consuming it. So you can continue to produce images however you were used to. Yes?
Well, to go on with this, what about Docker Compose files then?
What about Docker Compose files? Those are, at the moment, as far as I'm aware, not fully supported. But there is, it depends a little bit, because there is some support for Docker Compose style of running services. I would argue, though, how many people actually use Docker Compose to run services in production?
Too many.
Because the thing is, Docker Compose is very common in cases where you have to run something on your laptop because it's very convenient and everything else. But if you are running in production, maybe Docker Compose is not the most stable way of running services. Yes?
Is there some kind to refresh, to have a pull policy, for example, to restart the service?
What about pull policy for services? So, I don't think I'll be able to go back that much, but into the image declaration, you can put either latest or a specific version. I strongly suggest to put a specific version, and then if you do want to update, you simply change that version to the new version that you want to update to, and rerun the Ansible playbook, and it will update the service for you.
So you restart the service, and then it detects that there's a new version of the image, and then it will put it.
So the way it works is that, let me stop and go back.
Yeah,
So that I can show it to you. So, no, the wrong one. This one. So the way you would have it is okay. So since it's a different file, because you have changed it maybe here, let's say from version 1 to version 2, this is a different file from an Ansible standpoint, which is that what Ansible will do is change the file, because it's different, trigger the systemd daemon reload, which means that it will reload the daemon, and then it will also trigger the restart service, which will restart the service. And once the service is restarting, the new version will be downloaded and you will have it up.
I think the difference is in Kubernetes, if you don't set the image policy, it won't
Yes.
fetch you the latest. But this one will always fetch the latest every time, independent of what you do with Ansible, right?
So the question is this different from Kubernetes that has refresh policies? No, it's not different. The thing is, here is different because we have set it explicitly, the version. And that also works with Kubernetes. If in Kubernetes you explicitly say version 1, it will go for version 1. If it has version 1.5, it will renew and repull the information. Now, the reason you usually don't see it is because people usually use colon latest, which I think is very bad practice in the first place.
But this is just reference the image tag.
Yes.
You can update the image with the same tag, but a different SSH sum.
Yes, you can. You should not.
And the
But you can do whatever you want with containers and tags. But
if I restart the service, will it always refetch the
No.
same tag?
it will not refetch the image. The assumption is that you change the tag every time you change the image. If you are reusing the tags, it's like using latest. That's not a good practice because you then have no assurance that maybe you have, let's say, 3 instances of the same service, all running version latest, but you have no assurance that they are running the same version.
Yeah, but you could tag it stable and you cannot automatically update them. Basically.
But you have the same problem. Then you have 3 versions of the service that are running the stable version, but they are 3 different versions, which is probably not what you want.
It depends. If you want to say your service should always run the latest, then you use the Ansible to restart the service and you don't need to deal with tags.
Well,
That's what some people do. I don't.
the question is, can you simply put latest and then have Ansible restart the service and then have a policy that forces it? Yes, you can do it, but there is a problem there. Unless you restart Ansible with Ansible or with other tools, the service every 5 minutes, you have no guarantee that you are running the latest version, which is not probably what you want.
But you could remove the image and then it will repull.
Can you remove the image and then it refreshes? Yes, you can. You can also set the policy here, force renew. But it's like tags are there for simplifying the life of people, not too complex. Yes.
So the Ansible Podman container module can already generate podlets.
Yeah.
Yes.
Is there a reason why you use the systemd module instead in your representation?
Yes and no. I'm used to it. That's one reason. Another reason is that I like to have things that are readable in VI. And sometimes some Ansible modules make it less readable, not more readable. But yes, you can also use, there is the Padlet Ansible module, which allow you basically to not write this one, but to write a Ansible-like piece of code, yes. There was a question in the back? Yes?
Does it also support the Podman networks?
Does it also support Podman networks? Yes. You can declare it like this, or also with the module, you can also declare it Podman networks as well, and you can do all the usual things that you can do with Podman. It's basically, this thing is just creating Podman commands and running it for you. Nothing more. Another question or so? No? Okay. Yes?
So if you would run Podman PS as root, and even you gave them all the system D, the users and the group, you will basically get the overview on everything that's running under one host, right?
I think there is a flag for, the question is, if you are running Podman PS as root, would you see all the containers running no matter which users they are running on? I think there is a flag for that, because by default at least, you will see only the one that are running on the root.
Under the user that you issue the command types.
Sorry?
You see only the pods running for the user that you issue the command.
Yeah.
By default.
By default, you are only seeing the pods that are running under the same user as you are issuing the command from. Yes?
Do you support Podman user containers?
Sorry?
Podman user containers from the user system configuration?
So, the non-root one you mean?
Yeah.
Yes. So the question is, can you do this for containers that are not run as root? Yes, you can. Obviously, you will need to place the unit in a different folder, otherwise they will run as root, those kind of things. But you can absolutely use root as Podman as well.
All right, well, thank you very much.
Thank you.